So I'd like to thank Jason for inviting me. I have to say I feel woefully unprepared. All the stuff I've been listening to, you pretty much have to be a kernel developer here. It's not even enough to be like a normal committer, I imagine. You have to have invented something really cool. So I'm here as a user. I'll try to take the loser off of it. I didn't even boot into the BSD side of my laptop, so no rocks thrown up here. But what I wanted to talk about, actually, let me ask, how many people here have some kind of security responsibility? Okay, so wow, that's interesting. Okay, so there are a lot of security people here. I usually speak to security audiences. When I spoke before at BSD conferences, it was usually on something I was doing with BSD for security purposes. So I kind of had that same theme for today. So what we'll talk about, I'll just tell you who I am. I've worked at a variety of. I was in the military where I learned all this stuff. I worked in commercial industry, defense contractors. I worked for a small startup out of Connecticut. You might have heard of us. We've lost like $300 billion in market cap over the last year. It's been an exciting ride. It's General Electric. We got 300,000 users. Just a few security issues, as you might imagine, a company that size. But what I'm going to talk about, first I'll just do sort of an intro of how I think about security and why it drives me down the road of having the devices I'll talk about. And I'm open to any questions. It's funny, I was actually sitting in front of a couple guys who were talking about some of the software I'll talk about, and didn't even realize it was me sitting in front. So if at any point you have questions about how we do things, why we do things, please let me know. What I'm going to describe isn't exactly what I do at General Electric, or at least it's not officially what I do at General Electric, but you can imagine that I just don't come up with this stuff in a vacuum and then present it. Obviously, it's based on what I think works in various environments. So my job title is Director of Incident Response, and when I tell people that, they usually think of oil spills or hazmat or something like that. It's information security incidents. And I like to say that I'm as close to the problem as you possibly could be. Right? We have project managers who are trying to create risk equations, and they're trying to figure out if I tweak this knob, it'll result in more risk or less risk. I think that's a whole bunch of crap for the most part. I deal with all the failures, so I deal with failure all around. I like to say that there's theory out there, but reality is when, you've got dozens or hundreds or thousands of systems that are compromised, what do you do about that? So in some ways you might say, well, that's absolutely the worst possible place to do security is after it's failed. But in other ways, maybe it's the best place because you can see what's wrong and you can try to fix it. But you have to say, well, what is security? Right? I went to the doctor the other day, and the doctor asked me questions like, well, how do you feel? Do you feel healthy? That's kind of like, do you feel secure? So what does that even mean, right? I mean, if you think about health, you might say, well, how's your blood pressure? Well, it's under 120 over 80. That's sort of one data point. What about your cholesterol, body mass index, and so forth? But the idea is that you have to measure something, and you have to get your data from somewhere. And what I find is that a lot of people who make security decisions are not getting data from anywhere. In fact, a lot of very high-level security people are getting data on the golf course when they're talking to their fellow CISOs about, hey, what product are you buying from Cisco and this and that? And it's completely disconnected from reality. And as a result, nobody can tell whether they're spending any money on security that makes a difference or how to get better. So, and how many people here are sort of like involved in federal security with like FISMA and stuff like that, right? So I find all that to be the most frustrating thing possible. I don't deal with that because I'm in private industry, but I commented on it quite a bit because I have a blog and I like to complain. So my feeling is that the FISMA folks, not the implementers, but the people who wrote the legislation, they tend to focus on things like input metrics, like do you have AV? Do you have your patches? Is the box configured properly? I call all those input metrics. They really make no difference as far as I'm concerned if you're truly trying to figure out what the problem is. It's kind of like looking at a sports team, let's say an American football team, and you say, well, input metrics would be like, how tall are all the players? How fast do they run the 40? Where did they go to school? You can look at all those things, but does that tell you what their record was over the season? Did they win the Super Bowl? Did they win their league championship? No, those are all inputs, right? I care about outputs, like is this box part of a botnet? No, it's not running Windows. I could boot it into Windows, but prefer to stay out of the botnet. Did you have a disclosed earnings report appear on a network share or on a peer-to-peer network somewhere? That's an output. That means you had a failure somewhere. Do you have a system or a network that's unavailable due to a DDoS attack? These are all outputs. So I try to focus on these. I really don't care so much about that. I think these can influence these. These are the things that I care about. And just to sort of take it, just to step a little bit out and change the way you might think about this, there was a good article in The Economist last year where they talked about people who are trying to make policy decisions about health policy in Africa. And it's the same thing with security, right? And actually, that's kind of what I like about seeing the developers here is that in the last talk, there was lots of discussions about you made this change and you got a 5% difference, or you made this change, you got a 10% difference. None of that happens in security. It's all, well, we'll deploy this and see what happens. Actually, it's not even that. It's, we'll deploy this. Not even see what happens. There's not even a test to see if it made any difference. So what I've been trying to focus on in my job at GE is let's do some tests. Like, the company's big enough. Why don't we have part of the company run with no local admin on the desktop and another part continue running as local admin? I didn't say that out loud, sorry. And then compare and see what the infection rates are. And guess what? I bet the ones with local admin are going to be a hell of a lot worse. And there's been some recent studies on that showing that that's the case. So you could run these sort of policy-based trials and figure out what you should do. And if I can go to my boss and say, look, this part of the company that runs as local admin, they're 10 times worse than everybody else. And even better, I can say it's costing us 10 times more, then we can make a change. But in order to do that, you have to have some kind of measurements. You're going to have data to come from somewhere. And I like to say I call this management by fact and not by belief. There's a lot, like security people are very religious. We have this idea of what should be and what shouldn't be. And it's all because we don't usually measure what works, which is unfortunate. So I'm all about visibility. I want to find out what's going on, right? And the reason I think about it this way is I came from the Air Force, and we had this thing called the OODA loop. And if you ever see my hands doing this, it's because I'm reliving my Air Force days flying around in my F-16. Not really. I only flew once in the F-16 and once in the F-15. But when I would talk to the fighter pilots, they would talk about having this thing called the OODA loop. And it came out of the thinking before the first Gulf War. And the idea was you're in your F-16 and you want to win the fight. So the first thing you do is you look out the window. You see what's going on. That's your observation. And then you orient. You figure out, well, where am I in relation to where the bad guys are? Then you make a decision, like, okay, there's a bad guy. I better roll over and shoot him down. And then you take the action. And the problem we have in security is that there's none of this. There's no observe and orient. There's only decide and act. So we have no idea what's happening, but we're told to do things. So we buy stuff and we deploy it, and we just keep doing that over and over again. And we never figure out if it makes any difference. And the unfortunate thing is if you do stumble upon something that works, it's usually luck, as opposed to figuring out by observation and orientation what you should be doing. So this is probably my favorite description of security, period. My apologies to my European friends. This would be football goal security. But this is what I believe that I've seen this just for years and years and years and years. The idea is you are told, or you read in a magazine, or you talk to your buddy about something bad. And you assume that that bad thing that's happening must be happening at your location too. And sometimes it is, but sometimes it isn't. And so you run around and you spend all this time on one area, while meanwhile you could be completely owned by something different. And I first started thinking about this in 2000, 2001, where there were some guys in Finland who did this huge enumeration. They were doing some of the first fuzzing work against SNMP. It was called the Protos Toolkit. And they did all this work, and they found that basically everybody's SNMP implementation was really bad. And they were all vulnerable, and the whole world was going to end because SNMP vulnerabilities existed everywhere. Well, I don't know if everybody was around back then sort of looking at these things, but did the world end in 2001 with SNMP? Absolutely not. So a lot of effort was spent on spending all this time fixing SNMP implementations when the bad guys really weren't taking advantage of it. So this is what I feel like is happening in security now. We're told about, this is the one that really kills me, is insider threats. Oh, there's insider threats. they're so bad, this and that. And so you spend all your time over here and you're like paying attention to your own employees, violating their rights and their privacy. And meanwhile, you got like Romanians and Russians and Chinese and every other hacker in the world inside your company that you can't do anything about unless you actually do something. So my goal is to get it so that this guy is looking at the right spot, so at least he has a chance, right? He doesn't even have a chance if he's looking over there. At least if you can sort of orient and say, okay, well, here's the threat, here's what I need to do about it, you have a chance. You still might get scored on, right? But at least you can say, I had a fighting chance. Many organizations, when I was a consultant, I would drop into, and they didn't even have a fighting chance. There was just no, I would call them, indefensible networks. To use a Cisco term, I would call them the self-defeating networks. Self-defending, anyway. Yeah.
The network caught a virus.
The network caught a virus, that's right. So, yeah, isn't it interesting, the self-defending network? What does that imply? 0 headcount. That is the truth behind Cisco's vision. And think about it. They sell it to every CIO, and the CIO's like, yeah, the network takes care of itself. Oh, yeah, that means you, bye-bye, right? And that's sort of the model that, think about it. What business owner would not want to operate with 0 staff? If you could still make money and have no people, oh, that's great. Maybe you just have robots or something, right? They don't complain. So, anyway, wow, that came out of nowhere. But that's what I see with a lot of things. There's a presumption that you just buy products, right? You don't actually invest in people. So, back to this whole idea of visibility. The question is, well, where should you try to get visibility? And I'll talk about what kind of visibility. Well, the model that I use is to establish trust boundaries first. And what's interesting about using a trust boundary approach is it can apply anywhere. I use a network example here because it's a low-cost way to do it, but you could apply trust boundaries on a system, within an application. There's lots of different places you could apply trust boundaries. The idea, though, is once you establish a trust boundary, start watching something there. So I'm going to use a network example, but you could apply it someplace else. So what I do is the general process is I identify my trust boundaries, I apply some instrumentation, and then I collect, analyze, and escalate. Collect meaning I get the information, analyze, I look at it, figure out what it means. Escalate is I take it to somebody who cares. Surprisingly difficult to find those people in many enterprises. I came from the DoD where if we found a single machine that was compromised, that was an incident, and it could be reported all the way up to some general who would be on the phone like barking orders that you need to fix this within hours or days or whatever it was. To private industry where you find a compromised computer and the response could be, what can they do? Well, they can access any machine that's in this domain. Well, have they? Because I just got here, I can't tell yet. I really don't know if we have to care about this, right? The only thing that's changed that recently has been the disclosure laws, because there are some disclosure laws that say if it's possible that they could have stolen the data, you need to report. So that's changed the equation dramatically, right? It used to be, in fact, I worked some bank cases years ago where it was like, well, you guys had signed an NDA with us, right? Yeah, we did. All right, well, just bye-bye. See you later. I'm like, okay, great. All right, well, I'm glad I'm not a customer of this place.
Where do you bank?
No, I didn't respond there. I bank with Bank of America. And the reason I bank with Bank of America is I know the guy who runs security there. He does this. So, of course, I still think he has a job, now that I think about it.
Has he been replaced by a robot?
He hasn't been replaced by a robot. Many of his minions may have been replaced by tiny Perl scripts, but he's still there. So this is my general process. And it's funny, how many people have probably heard about building security in? That's great, let's make things more secure. Haven't we been trying to do that for 20 years? It just doesn't work. So what I would say is let's monitor first, because at least when you monitor, you can tell that something bad is happening. If you just say build security in and walk away, then you're in trouble. What I find is that in any product, you have this cycle where you start out with a feature, and then the features proliferate and you need to manage them. and then somebody's like, oh yeah, we need to apply some security to that, and then finally you check to see if it works, when really it should be the other way. Like, figure out what's out there, build a security policy for it, manage it, and then introduce the feature. But that's not how it's done. I wanted to mention here so I just wanted to put this on the table before I go into my next part, because these are the criticisms I usually hear, so let's just mention them now. So if I'm taking some kind of network-centric approach to security, the first thing I'm going to be told is, well, what about the cloud? And this is very interesting. I work really closely with the guy who does the cloudsecurity.org blog, and he's a fellow employee with me. So we are always considering this, because we're putting more and more of our stuff in the cloud. And if your window to the cloud is an SSL encrypted pipe, it doesn't really help you too much to inspect it at the network level, right? So we're going to have to push our cloud vendors to provide the visibility for us. Oh boy, that's really happening. Try getting good logs out of any of the cloud providers. It is absolutely horrible. They don't want to store them. They don't want to provide you the data in any format that's useful. If they provide you with anything, it's generally performance metrics, like, we cleaned 10 billion of your emails today. Oh, that's wonderful. That's great. I don't care. I don't care how many emails you cleaned. I want to know about which ones came from this person who was phishing us, who then got control of some of our systems and so forth. Virtualization is obviously an issue. If you think about in a one machine, one platform world, anytime two machines talk, you could potentially see the traffic. But what happens when you have 100 machines all on one platform? Unless you instrument the virtual machine itself, the 100 machines could all be infected and talking to each other and stuff. But the way I deal with that is, unless the bad guy is also inside the VM, like he lives in it, you can see him, because generally the people you care about are on another continent. So, they could be somewhere else in the United States, obviously, but for the most part, like if someone were to compromise my machine, unless they physically walk up to it and touch it, there will be some network traffic that reaches out. And generally that's enough to tell that there's a problem. Does anybody know what the fastest way to tell if there's a kernel mode rootkit on a system? It's for the system to look normal, but to have it be beaconing out to, take your pick of rogue country. So that's a very effective way we use to find stuff. And then, of course, you've got your non-traditional platforms. I've got my BlackBerry here. I absolutely love it, but I would love to be able to sniff the traffic going to and from it, because who knows who's sitting on my BlackBerry right now? I really don't know, and that kills me. It kills me that I cannot find an interface, sniff traffic on it, and see what's happening, or somehow get between the wireless, watch the traffic, and see what's happening. So that, to me, is a big issue. Then we've got all these crazy European privacy laws. I can't collect anything in that whole continent. Not true. It kills me, though. It's kind of difficult. You've got this tension between... it's interesting. The Europeans tend to have very strong collection laws, like you have to keep logs for a certain period of time. But at the same time, they have very strong privacy laws. So there's a tension there. Skilled resources. I don't know about you, but even with the downturn, it's tough to find good security people, I think. There's a lot of people who come out with their Cisco certified whatever, and they don't know the first thing about how to actually secure anything, which is tough. And then finally, we see this quite often in the software security space. A lot of the tools that are out there were built for developers and for performance and not for security. So you see people using tools to disassemble malware that were built for reverse engineering for software purposes and not for security purposes. Anyway. So what I'm going to talk about briefly is not new. I was actually cleaning out an old drive, and I found this presentation from 2000. And I used to give this briefing when I was in the AFCERT, the Air Force CERT. And we would talk about the history of our unit. And back in 1993, we were deploying what we called network security monitoring systems. And the NSM term comes from the first network-based IDS that Todd Heberlein wrote at UC Davis in '89. So this is, wow, that's 20 years. I feel freaking old right now. It's amazing. So this is not a new thing. And I wrote a book about this in 2004. So that's 5 years ago now. So this is not new. The funny thing is, the vendors is finally starting to catch up with it. And they call them network forensic appliances. And they charge you $50,000.
Of course, it's enterprise.
For the enterprise, that's right, because it has a GUI. Click.
Enterprise really just means expensive.
Yeah, enterprise means expensive. I like that. That's good. And GUI.
Don't forget the GUI.
And GUI, that's right. And somebody you can complain to who can't really answer your problems. So, all right. So when I present this because I don't want to take credit for this approach because we were doing this a lot. I came in around here, but we were doing this earlier. So I learned from people who invented this stuff. Wow, that's like 15 years ago. All right, so why network sensors? I have to say, some of the artwork I saw in these presentations were so awesome. I feel mine's terrible. I mean, it was the Lego stuff. That was great. I need to do like a little Lego pyramid. I really like that. But this,
I refrained from building the later X-Fix stuff with Lego. I didn't have enough bricks.
I was actually wondering where you got your bricks from. I have to like raid my kids' Lego bricks.
I went to a store and bought them. The lady was very confused by the request for big bricks of the same size and different colors.
That's funny. That is funny. That was good though. I'm a visual. I was right in there with the bricks. So I call this my Tau Security Enterprise Trust Pyramid. I ripped this out of something I used to do when I was a consultant. And basically it's a justification for why it's good to have network sensors. And the idea is this. This is the least trusted part, and this is the most trusted. And I should have brought I've got a pointer, but never mind. That's low user interaction. This is high user interaction. And this is also in terms of numbers of devices. So in any enterprise, you tend to have the most user platforms. Desktops, laptops, phones, all that kind of stuff. Above that, you have servers. Above that, you have infrastructure, routers, firewalls, things like that. And then above that, you have sensors. So I trust these the least because there are these users, right? And users are doing things like interacting with the system. If they didn't interact with the system, I probably would trust it more. But because they're on the system, they could be running as an admin. They're going to all these malicious websites, even normal websites that have been owned and are injecting malicious JavaScript or whatever. So the more user interaction there is, the less likely I'm going to trust what that system tells me. So if I get on a system and I say, tell me how you're feeling, what's your state, I'm not going to trust that system. AV is generally worthless. You have to get outside of the system, and this is the key point. You have to get away from these things. You have to get outside the system to get a view of whether or not you should trust it. But that's not the case, right? We're moving more and more to pushing all the security down into the endpoint. So my laptop defends itself. My phone defends itself. And guess what? If they fail, the whole model fails as well. So above that, we have servers. I trust servers a little bit more because if you're a good admin, you're not surfing MySpace on your Windows server, right? Well, you're not on a Windows server. But, you can be a good admin on a Windows server, but you know what I mean.
Only because they pay you?
Well, because they pay you, that's right, that's true. Above that, you have infrastructure. No one should be, in general, no user is directly dealing with a firewall. If a user is logging into a firewall, there's a problem, right? A user doesn't necessarily log into a server, but it uses services on a server, right? So I tend to trust these even more because users can't touch them. The number of people who deal with the infrastructure is generally smaller than the number of people who deal with the servers. And in many cases, the infrastructure is completely invisible, right? How many people interact with a router when you're sending traffic through it? No, you passes traffic. Same with the firewall, blocks it, allows it, whatever. So I tend to trust what this will tell me even more because there's less user interaction. The final stage here is my sensor. The sensor is completely passive. Most of the people in the company might not even know it exists, which is good in most cases, unless you want a deterrent effect. So I can get data from the sensor. Typically, in my team, there's only 2 people that even know the root password. We can heavily defend these things. We can have them defend each other, watch each other. So I tend to have a very, very high confidence in what a sensor is telling me, as opposed to what a user platform is telling me. So if I'm on a user platform and I'm looking around for evidence of a rootkit and I see nothing, but up here my sensor shows me traffic going by out to some site in Brazil, then I can say, all right, we have a problem here. So this is why I like to introduce these sorts of devices. Let me talk a little bit, too, about the least trusted or most trusted. If you had to rank operating systems here, would you put Windows up here and BSD here, or the other way around? Right? So I like to use BSD, especially for my sensors, because I introduce what we call a technology gap. My company, we use a lot of Windows, as you might imagine, and we use a lot of Linux. We don't use a lot of BSD. In fact, I'm probably the only BSD shop in the company that I know of. But that's good, because if you're a bad guy and you get inside the company and you root our Windows infrastructure and you root our Linux infrastructure, and then you find some BSD boxes and we administer them ourselves, it's going to take a lot more work to get into those systems. And we're probably going to notice when you're trying to get into our systems. So it does not make sense, and I've seen, we get a lot of pressure on this internally, and I've seen in other companies, to have our sensing infrastructure be integrated with the rest of the company infrastructure, right? Oh, just have it be on our hosted Linux service, where you could have potentially all these admins you don't know on another continent logging into your devices. I was like, no way. I want a gap. I want the stuff that we have to protect not be the same as what's using, or not be the same systems that we're using to watch those. So I introduced BSD as a new operating system to watch those. Yes?
Do you stay on Intel platform?
So the question was, do I stay on the Intel platform? I actually bring up that point in my forensics talks. I am on an Intel platform for my sensors. However, depending on how you want to do forensics, for example, I have done cases where I've had one tech stack where I've got Intel, Windows, ToolX, whatever, and then another platform where I've got PowerPC, Debian, blah, 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 something completely different. And I will say, by the way, I don't run the one system I expose in my home lab is not an Intel system. It's a PowerPC, it's a Mac Mini, and it's running Debian on top. I tried to put NetBSD. I had a problem. I don't know what it was. Probably user error. But so Debian is running on that. And what's nice about that is, do you remember when all the Debian what was that? Is the SSL stuff? That happened recently? All of the pre-compiled exploits for that and all the pre-compiled keys, the shellcode was all wrong because I was running PowerPC. And when I did my update or whatever, I was like, I wonder if I'm affected by that. And it kept saying I wasn't, even though I knew I was, because I had the vulnerable library version. And I was like, oh, that's right. This isn't an Intel box. It's a PowerPC box. So I do use that diversity argument in very, very limited situations, but it would be really expensive for me to say buy, 80. I don't know. I'm not even sure what I would use these days. It would be tough to find that I could get at a good price and everything. So I have to make some compromises there. But that's not a bad idea if you had to have some kind of central server that was going to watch everything. Maybe you do go that extra step to make it even more diverse. All right, so I'd like to talk just for a minute about what I do like to deploy. What's my time here? So I'm involved with this open source project called Squeal, S-G-U-I-L. Squeal doesn't stand for anything officially, but it originally, when we first wrote it in 2000, by the way, Bam Vischer is the lead developer. He's actually probably the only developer. The rest of us are just lamers. That's what the L means. Originally, it was Snort GUI for lamers. But then a couple people who got it, who didn't get the joke, they got the software I'm not a lamer. I'm not going to use your software. I'm like, well, I don't care if you use it or not, but yeah, right. Yeah, right. But we felt okay. That's kind of we'll just call it Squeal. It doesn't mean anything. So I'm going to talk to you about Squeal. But the thing about Squeal, remember, is it's open source. It runs on pick your distro of choice or flavor or whatever you want. It's more about the data and less about the tool. So you could potentially implement all this with your own tools, even commercial if you wanted to. But it's really about a way of getting data and thinking about it, and less about the actual tool. Anybody know who that is? It is Elvis. Anybody know what martial art Elvis studied?
Aikido. Not the one by the guy from Hawaii.
Yeah, Ed Parker.
American Capital.
Yeah, American. Yeah, very good. So that is Elvis, and Elvis is the patron saint of this system. I don't know why. It's been a really long time, but I love Elvis because he's in his Kempo karate stance, and his stance is like this, which it would take him like a week to get out of this fighting stance if he actually had to do anything. I actually won some concert tickets by stumping an Elvis expert on a radio station here in D.C. I called in and I said, what style of martial art did he? He's like, oh, karate. I'm like, what style? I don't know. Kempo karate. Well, who's this master's name? Ed Parker. And they're like, oh, you just won those tickets. You stumped the Elvis expert. So here you have Elvis. I'm gonna contrast these two methods of doing investigations, right? So you get Elvis. He's your analyst. You don't want to piss him off because he's Elvis. He'll hit you with his magic karate chop. He gets an alert via some system, right? Hey, well, not in these days. Look at him. He's looking trim, man. He's got his. By the way, if you've ever watched him in concert, he's doing Kempo like throughout the concert. All the moves he's doing Kempo. You zoom in, he's got a Kempo patch on his whatever he's wearing. You look at his guitar, it's got the Kempo patch on it. Like once you're exposed to the fact that he did this style, it's everywhere. In fact, there was one, he did a concert once. Actually, he didn't do a concert. He attended somebody else's concert. And I don't know who it was, like Johnny Cash or somebody, saw him in the audience. He's like, Elvis, you want to come up here and do a song with me? And he's like, oh, sorry, I'm under contract and I can only perform at this one casino. But I'll tell you what, I'll come up on stage and do karate. So this is another guy who was doing his performance and Elvis is just jumping around doing karate. I got to find a video of that. That'd be great. So anyway, Elvis is here, and his job is to find intrusions. So he gets his console and he gets an alert, and he looks at it, and he says, all right, well, I got to figure out if this matters. So what do I have to work with? Well, I have other alerts, like picture in front of some Cisco device, right? Like a NetRanger or whatever they are these days. So he queries a database and he gets more alerts. And he says, well, this is nice, but I can't tell if any of this matters. So that's the end of the line, right? At this point, he's got two options. He can either ignore it, or he can satisfy his 15-minute SLA that his customer pays $3,000 a month for, call the customer and say, I saw this, I don't know what it means, ball's in your court, goodbye. So I don't know how many of you have had that experience with an MSSP, but that's very, very common. So to me, that's completely worthless. So this is the alternative I propose. So see, already you can see there's more lines, so it must be good, right? So you got all this. He queries this data, he gets an alert, he queries the database, he gets the same alert. But now the difference is he has some data to look at. In other words, it's not just an IDS or whatever generating alerts, there's some evidence to review. And the key idea behind NSM is the evidence is collected whether or not it has security value. That's not quite right. What I mean is you're always collecting data because you don't know what is useful. In other words, if you knew what was bad, why don't you just stop it? That is the whole fallacy of security, right? Like the whole thing with IDS was, if you can detect it, why can't you prevent it? Oh yeah, right? So you invent this whole IPS category, which is a silver bullet, which did really nothing. But the idea is, yeah, if you can detect that it's bad, why don't you just stop it? Well, of course, that makes a lot of sense. So you have a lot of stopping bad stuff, but then there's other bad stuff that's happening because you don't know it is bad right now. I mean, I learned these techniques dealing with intruders, and I'll date myself, but in 1998, intruders in China who had written their own virtualization platform on top of Solaris, who were doing stuff we're like, holy cow, because we had no idea that they could do that sort of thing. So there was no system that was going to detect it because we didn't even know it existed. But guess what? We were keeping track of everything that was happening, and once we knew what to look for, we checked our data and we're like, holy crap, they've been in here since 2 years ago. Right? This slide that I showed you here, when we started putting out these sensors, there was huge resistance. This was like, oh man, we're the Air Force. We just defeated Iraq, the 4th biggest army in the world. We kick ass. There can't be anybody inside our network. And we're like, please, can we put a few sensors out there? And they're like, all right, yeah, but you guys are wasting your time. So we put our sensors out, and what do you think? What did we find? We were owned everywhere, up, down, left, right. It was terrible, right? We were completely owned because nobody was watching. And then after that, boom, that's when everything took off. So the key here is that you get your alert, but then you have data to look at. And the three main forms of data we collect. We collected alerts, but we're also just logging all the flows we see. We call it session data, but it's just flows. right? And we typically deploy our own software to log the flows. But the key is we don't log the flows that are associated with the alert. We log all flows. So you don't have to know what's important beforehand. You just keep track of everything. And then once you know what to look for, you go look for it. I kind of liken it to the Splunk model. Like, how many people have used Splunk? Right? Splunk is really awesome, right? Splunk is the place you go when you know what to look for. You generally don't have Splunk tell you stuff. I mean, you can, but for the most part, you want it to be there when you need to ask a question and have some response. It's the same thing with this. Once I know what to look for, I need a place to go look. So I query my sessions, and I'm like, oh, well, look, this guy just reached out via FTP and grabbed his tools. Guess what? Most hackers these days still do this, right? They aren't like SCPing out or whatever. Yeah, but go and grab their tools over FTP. Excuse me. Well, they grab their tools over FTP. While they're doing that, I'm logging all the packet data. And a lot of people used to say, oh, Bejtlich, you're crazy. Who can log full packet data in all their gateways? The NSA does. So guess what? We can too, right? It's not that tough. Most network connections are DS3s or less, at least the outbound ones to the internet. So you can log a lot of packet data. I mean, hard drives are cheap. They are cheap, so you can grab a lot of data. Yeah, question?
What do you use to dump all the data?
I'll walk you through all of it. Yep, yes.
My question is, so I'm located, my servers are in Maryland.
Yes.
I'm an ISP.
Yes.
What happens when I get stuff from Massachusetts or California and they're going, you can't do that?
Yes, okay, so there's two things. The first thing I thought you were going to go down was, I'm an ISP, do I do this for my customers? The answer would be no. I would do this for my infrastructure. Okay. As far as the privacy stuff goes, we're wrestling with that ourselves. And what I end up doing is typically scaling back to what the law will allow, and then showing that it's either adequate or not adequate, and then I take it to the lawyers and say we have to somehow push back against this. Yeah. But okay, so imagine that you do grab the full content, though. And by the way, this isn't theoretical. We do this all the time. I have a reverse engineer on my staff who, when we see machines going out and pulling down their binaries when the machines are owned, I pass him the traffic. He pulls out the exe, he reverses it, figures out what it does, and now we go into the next stage of incident response. So it can be done. So then we say, oh, shoot, it uses this back door. We go back and look in the sessions, and we say, oh, I see this back door. Let's go and look at the traffic. And it just keeps going. So the idea is that this isn't the end of the investigation. It's the beginning of the investigation.
I want to throw out there real quick. Not only can it be done, it's easy to do and can be done completely free as in beer.
Yes, and that is very true. Everything that I've shown here, you could literally walk out of here, go into the FreeBSD ports tree, find the squeal ports, do your make. I mean, the ports are a little. I'm not. You don't want to slam a guy who volunteers and makes ports, right? But there's still a decent amount of work that you have to do once the port's installed. It's good for basically satisfying dependencies and so forth. But so this is the implementation we use as far as software stack. For alert data, we use Snort. I've used Bro a little bit. I'm starting to integrate Bro, though. Full content data, I tend to use Daemon Logger. It's Marty Rush's implementation of Packet Logger. For session data, I use SANCP, which is what a friend of mine wrote, but you can see some other options there. And then statistical data, think MRTG, any type of thing that shows you traffic over time or whatever. And the nice thing is Squeal is the interface to a lot of this. And I'm going to show you what that looks like. By the way, so this is it in a picture. So what is Squeal? Well, okay, yes, this is a Windows screenshot. It shows that you can run your BSD backend on the servers and then have your boss use his Windows GUI and log into it. And again, this isn't about the tool as much as the data and the way you investigate it, but here's some screenshots. So you can see we have a console here, and these are our Snort alerts coming in. By the way, they can be other things. We've got, this isn't a SIM, incidentally. We were talking just a few minutes ago, like the way we describe it is, with a SIM, you can put A, B, C, D all the way through W into a SIM, and it can still be garbage. But with this, we pick the X, Y, and Z that we think give you the best value. So for us, those are alerts, sessions, and full content. So you've got your interface here, and we try to present as much information on one screen without having to do a bunch of window management. And yes, it is TickleTK. We started this back in 2001. but it works. It's fine. It's cross-platform. So here's the packet that caused the alert. Here is the rule that caused the alert. And in most systems, this is what you would get, right? You're left deciding if it's okay in an HTTP transaction for someone to have put through what looks like the output of a ID command on Unix, where the result was UID 0. Is that good or is that bad? I mean, you'd probably say that sounds bad, but once you do the analysis, you'll find out it's not. The question is, you have to make that decision. And every vendor that I've met, they leave you here and they abandon you. They say, good luck, I've given you the packet. Like, you'll talk to the SourceFire guys, they're like, I gave you the packet, what more do you need? I need to know if it matters. And they're like, well, I gave you the packet. Right? Like, yeah, packet. So what? It's a packet. I can't tell it. I can tell there's a packet here. Yes, there's a packet. And yes, it's nice that you gave me a nice open rule so I can tell how it came to its decision, unlike, a closed system where you can't tell. But I have to tell if this matters for me. So what do you do next? Well, you can do a couple things. One thing you can do is build a transcript. The transcript is all of the session rendered through, in this case, we use TCP flow. So we say, literally, right-click, give me a transcript. System goes out to the sensor, pulls back the PCAP data, renders it in TCP flow, colors the blue, the source, the red is the destination. So you can see that my system visited this www.testmyids.com site, and it replied with the content. So there is no like backdoor on port 80 here. This is and by the way, the other thing that's nice is I can see I came through this proxy and whatever. If I'm dealing with a binary protocol, like let's say SMB or RPC or something that doesn't render well as text, that same right click you can instead choose to dump it into Wireshark. So here's the Wireshark data, and you can use anything you want to do with Wireshark at this point. This is fast, right? I don't know how many of you have had to do this by hand. You SSH out to the sensor, find the PCAP file, come up with a BPF in your head, run it, copy it someplace. No, this is right click, got all my data. If you want to see, well, have I ever gone to that IP address before? I query from my sessions, and I say, in this case, it's a SQL query for that dest IP. And by the way, you can right-click and do a default query, or else if you know what the schema looks like, you just modify it by hand. And I think that's it. So if you want to try any of that, like I said, the ports exist. I maintain some really lame scripts that automate this when I need to install it on my home gateway or something like that. They're more of just a reference. But that's what I do on BSD as far as network security monitoring goes, and I'd be happy to answer any questions. Yes?
What kind of additional features are you looking for in the future, or where
for Squeal?
BSD has right now?
Yeah, so I would say for Squeal, for new features, the first thing we need to do is resolve intellectual property, because I hired BAM as my lead incident handler at GE. So we need to figure out if he works on it at work, can we release it back into the, well, first of all, can he even work on it at work? And secondly, if he does, can we release it? So we're trying to work out those. I think it'll be resolved positively, because GE is actually fairly pro open source. I told the CEO of the company that this thing used MySQL as a backend. He's like, I love MySQL. Okay. He's like, you got your money. I'm like, oh, okay, that's what I had to say? All right, great. He hates Microsoft. He hates the company. It's great. Yeah, it's amazing. So we want to, once we get that resolved, we want to probably introduce other data sources. So like introduce, Bro plugin, some other agents that could accept other data. We need to have some kind of reporting mechanism, because people want to know what comes out once you put it in. There's been some talk about making this turn into a Splunk-based application. So all the data goes into Splunk, and then you could use Splunk as the interface. So that's a possibility. Yeah.
Willing to license Splunk.
Yeah. So
I've got the money to license Splunk.
Yeah, Splunk is remarkably cheap for an enterprise app, though. We've bought giant licenses that have not. They've been 5-figure purchases, which is really good considering how many gigs of data we're indexing. But for the situation here, it would be an option, because the free Splunk is 500 megs a day, so that's not bad. Any other questions, sir? Yes.
What are your what's your experience with Bro versus Snort? Like, how has that played out? Like, is there a lot of value added by Bro?
Yeah, I think Bro is a perfect. So if you've never heard of Bro, bro-ids.org. In fact, I'm going to the Bro training next week in Berkeley, which is just going to rock. I'm so excited about that. Bro, I think, is a perfect complement to Snort. Snort, not exclusively, but Snort is quite a bit about signatures. There are some preprocessors that look for protocol anomalies and so forth. But Bro is almost completely the opposite. Bro is all about protocol anomalies. Snort has kind of like real hackish type state keeping using flow bits. Bro is all about state. So you put the two of them together, you might say, shoot, I really need to know when such and such happens, but to do that with Snort, I'd have to do all these flow bits and stuff, whereas with Bro, you're like, oh, just track the connections and then do this. So the two of them together, I think, work really well.
Doesn't Bro have, like, Snort rule import functionality?
Okay, the question was, does Bro have Snort rule import functionality? It does, to the extent that every, like, hardware vendor, accelerator vendor, Snort competitor says that they do. Snort the engine is always being updated. So generally, when somebody says that they can run Snort rules faster, they're usually only talking about content matches. So they take whatever the content match is and implement it quickly in hardware. So over time, the degree to which you can map real Snort rules fades. So whereas 5 years ago it might have been like 90%, these days it's like 25%. So they probably can pull in a certain percentage, but not a lot. Yes?
If you're keeping the packet traces basically full, what kind of retention policies do you find make sense sooner or later? You're not being safe.
Right, exactly. So the question was about retention on the full content data. I should have mentioned that for alerts, we try to keep about a year. For flows, we try to keep about 6 months. And alerts and flows are both centralized, although given the flow volume we're seeing, we might have to start pushing that back onto the sensor. PCAP data, it is just what we can afford as far as hard drive spaces go. My last budget, I could only spend about $2,500 to $3,000 per sensor, which limited me to about 1 terabyte of disk space with RAID. So depending on where that sensor goes, that could be 3 months or 3 weeks. Or a day, or 3 days, or 3 hours, right? So what I do is I buy up chassis that can potentially grow to have a lot more storage once I have budget. I put the system out there and I say, look what I found at this location, boss. If you give me a little more money, I can put in 4 terabytes of disk space as opposed to 1, and then they give me that. But the PCAP data only stays on the sensor. So what I try to do is I have an analysis window and a PCAP window. And I try to have the PCAP window longer than the analysis window. Is there other questions? Yes?
I assume it's still applied to SSL.
Yeah, so any type of encryption, I'm hosed. But the funny thing is, most of the time when I get any type of like third-party tips, it's usually, have you seen anybody visiting this IP address? And if I see the visit to that IP address, even if it's encrypted, I know, because this isn't the whole game, right? Usually what I do is I use all this to identify boxes that have problems, and then I roll in to do host-based forensics. So that's sort of the other side.
I was thinking it would be cool if you could have, you notice that weird behavior, you can go fetch the key from that server, drop it in Wireshark, have it encrypted or something like that.
Yeah, that is really dependent on the way that the encryption algorithm is implemented. Some of them are very friendly to that, others are not. In others, in some cases, it might be better to use another approach. Like there are certain proxies that are out there, like the Palo Alto firewall. You can specify encryption policies. So if you go to banks, if you go to certain sites, they don't mess with the SSL. Everywhere else, they man in the middle it. And so you could get access to the logs that way. So I try not to do that with the sensors so much. I try to make the sensors so nobody even knows they're there, if at all possible. Yes?
My experience with some of the bots using the squeals is that while some of the traffic might be on 443, there is inevitably traffic that's not going to be on 443 that's usually on 80. So even if you can't see the 443, there's no evidence to tip you off of the other traffic. So.
Yeah. His comment was, even if there is 443 traffic that's encrypted, generally there'll be something else that isn't. And that's really what all this is about. It's generally about getting a hint that something is wrong and you don't necessarily know what the hint is until you've been burned pretty badly, and then you go back and you figure out what the scope of the incident is. In no forensic case have I ever worked where I had a complete picture. I had the guy's hard drive, I had his logs, I had his network traffic. It's generally, you get some piece, and then you start investigating. And the reason I do this approach is because it's cheap. $2,500 commodity hardware, open source software, a little bit of experience, and suddenly I've got some valuable data. You'd think working at GE I'd have some huge budget. No way. Not at all. Any other questions? Yes?
You mentioned using BSD just to have maybe something that you trust.
Mm-hmm.
Is there anything from a performance perspective or anything else where BSD matters? Or really could you run that on?
Well, to tell you the truth, I started using FreeBSD specifically in 2000, and the reason was our developers who were building the ASIM sensors in the AFCERT, they said if we're going to have a good network stack, we should use a BSD-based stack as opposed to Linux. So that's how it started. Since then, there have been many changes in both sides, Linux, within the BSDs, and so forth. So I'm really not in a position to say which is better. I would say I've never had a BSD let me down, put it that way. And as far as FreeBSD goes specifically, there's some minor things that make my life better. One is I know a lot of the network developers, so when there's an issue, I can talk to them directly, and they can say, like some of the, I don't know who's here from the free, but some of the zero copy stuff that's being worked on, that helps me a lot. Some little stupid things like the ability that any app which is opening up a BPF, you can track performance with netstat-b, capital B. Little things like that are helpful too. There's another question. Yes?
So just out of sheer curiosity, you had mentioned offhand a story about some recruiters 10 years ago who had written their own, I think you said, virtualization layer.
Yeah.
Can you elaborate on that a little bit, or at least clarify what you mean by virtualization layer?
Yeah, so I don't know if what you've seen in the news about Chinese hackers and all. This has been going on for a long time. It's just that nowadays they're mostly on Windows, but 10 years ago, what was popular in commercial and military? It was Solaris. So we were seeing all sorts of weird traffic to our Solaris boxes that we couldn't account for. So these guys had written, once we started doing some forensics, and it wasn't the forensics of pull the power cord, which is what was popular back then, right? It was, let's take actually I think back then we generated a crash dump, right? And then analyzed it. So these guys were writing memory resident, did not touch the hard drive implementations where they built their own hypervisor that had their own little operating system on top of our Solaris boxes that we couldn't see. Yeah, so that was back then, right? I've worked on that side, the defensive side. I've also worked on a not defensive side. I won't say what that is, but the stuff I saw there that we were doing as contractors, I was like, wow, this can be done. This is really amazing. So most of the time, if you have an imagination, you can sort of imagine what's happening. And if you think about it, you might think, well, we're not the only ones in the world who can do that, so there's probably guys on the other side who can do it, so then you have to start looking for it. What you see is a progression of things that happened at the very high end. Eventually it filters down. Really good rootkits used to be the province of people who wrote them, but now you can buy them, find them, share them, whatever. Yes?
You do anything with pattern analysis, saying oh wait, this looks bad, why are they all going to Latvia?
Sure, yeah, so the question is, do we do any pattern analysis? There's nothing bad about Latvia. You asked a good question. Let me put it this way. I'm creating the first GE cert. It's 2009, but yes, we just stood up our first cert. So we're not even crawling yet. We're like the baby on its back, oh look, I can lift my head up. So we're still getting our hands around what does it even mean to operate the cert, data we have, and so forth. I would expect within the next 2 years we're going to be doing the kinds of things I would have expected, a real cert to do, and that will include things like we know our environment so well that when we see that box doing that, that's outside of scope. it's one of those things where we have ideas that are probably like 2 years ahead of where we can implement. But once we do, yeah, we'll find stuff like that. Yes?
Have you thought of getting people to write neural nets for you to do it for you?
Have we gotten people to do their own what?
People to write neural nets or AI to do that for you.
Yeah, so the question, so I think you probably heard the question. We are actually collaborating with ICIR at Berkeley, like Vern Paxson and his guys, the Bro guys, and New York University. So there's 2 research programs at each, and we're going to be probably, I would guess we're probably going to ship them data, because that's what's great about our method, right? We just collect data, so we can sign an NDA, ship them data, and they can apply all their different research theories against it and find stuff for us. So yeah, I'd expect some of that from those guys. Yes?
What are your thoughts on like inline IDS versus passive? Are the sensors normally just passive listening?
Yeah, so the way I deploy is I use taps where possible because you can't screw it up. I mean, you can. There are certain fiber taps you can physically connect backwards, so just enough light will get through so the traffic follows, but no light is reflected out to your sensor. But for the most part, if you're talking copper, dumb tap, it gives you your traffic. I even prefer that model for like IPSs. If you have to use an IPS, use a bypass switch as opposed to putting it in line. I don't put anything in line because as soon as you're in line, what happens? You get blamed. So I'm like, look, I have a dumb tap, pull the power cords. It's not going to affect the network in the least, right? My sensor could blow up in a ball of fire and you wouldn't even notice it. And all the business owners are like, yes, okay, yes. But if I told them I'm putting this box in line, anything that happens, they're like, your box took down my $10 million an hour system. I'm going to kill you. So I don't bother with that.
How many times have you heard that?
None yet. I got a good track record. That's why I'm still employed. So far. The only time I ever took something down, I was fully authorized to do. We had some script kiddie who was defacing website after website. We had some, Microsoft IS-40 websites back in the Air Force, and he was dialing in, getting a new IP, defacing the website, disconnecting, dialing in, so we had a new IP. So we had all our admins trying to block these IPs, and we're like, this isn't working, and stupid defensive policies. This is all like at 2 o'clock in the morning Eastern time, or actually no, Central, wherever I was in Texas. And so finally I said, this guy is all over the space. He's in California. He's using UUNet. The UUNet block, or however they're assigning the IPs, it's just all over the place. We are blocking UUNet, all of UUNet to the Air Force. So I was like, execute that blocking order. And, and I knew there's going to be hell to pay the next morning. So the next thing I did was I started writing, this is why I blocked this, whatever. And I had tons of generals. I couldn't check my email. And I got up in front of the generals and said, sir, this is why I did this. I did it to protect the Air Force assets and all that. So I was all right. One more question?
One more. Has anyone to date attacked your sensor systems at all?
Yes. The sensors are scanned all the time. I use them. The model I use with the sensors is you don't firewall things off like you might on a Windows platform. You disable things. I mean, it's the traditional Unix. If you don't need it, you don't turn it on. So I typically only expose SSH. The systems reach out. They don't, all the things you would think that is what I do. And of course, they're scanned, and people try to brute force them. And of course, if I see somebody brute forcing my sensor, it's like, who are you? Because these are all internally managed, right? I'm like, whoa, who are you? Why do you even know that this box is here? We're going to come and get you. Sounds better than it is.
How many black helicopters do you have at your disposal?
Yeah. We're selling.
After the conference.
Yeah, we're selling our fleet of black helicopters actually. Yeah. Exactly. Yeah. We don't have a fleet of corporate jets like a lot of other companies. We have NetJets accounts. Well, I don't, but the CEO does. We do have a helicopter. I've seen it once. Yes. Yeah, so the question is, would a honeypot be of any value? Honeypots are things that are good to run if, one, you're a researcher, or two, you have a lot of time in your hands. Because I have like a network of 300,000 honeypots. So actually, it's more like 500,000 now that I think about it. So yeah, at some point, there's actually two things. One is, at some point you could deploy some honeypots if you see them scanned, but I have enough systems that are live that are getting scanned or attacked or exploited. The second thing we have is if you're inside our network and you try to do anything to any network that is not explicitly routed by us, you end up in a sinkhole. So the sinkhole is an awesome place to find misconfigured systems, malicious systems, and so forth. So I have a sinkhole router, and before that I have a sensor that watches that traffic. So the sinkhole router is a great indicator, source of indicators. It also keeps a lot of load off our firewalls. So you can't scan Google from inside GE, for example. It goes straight into the sinkhole. I know Capital One does that as well. It's a good trick. Any other questions? Okay, thank you very much.